Hey guys, the notes that you have for 4-3 rate of change slope are going to be slightly different than what I have here. This is a section that you can be overwhelmed by, or we can be straight to the point. So I've kind of revamped them to go straight to the point, and really dive into what actually it is to be rate of change and slope. All right, so these are, again, revamped notes. You can use what was given to you. You can write these yourself, or you can simply listen and follow along to what you need to do. All right, we're going to be taking a look at rate of change and slope. So the first thing that you need to understand is that they represent the same exact thing. So when a question asks you for rate of change, it's asking you for the slope. When it's asking you for slope, it's asking you for rate of change. These are exactly the same two things. So you need to understand that these two words are interchangeable, okay? Rate of change is that first difference. So when we found quadratics and we had to find the second difference, understand that rate of change is finding the first difference. We're finding that change of the output and the change of the input that's taking place. Notice this is written in fraction form. All right, so output over input, and it is written as a fraction. So we need to understand that then slope is this rate of change, but it's describing how it's graphed. It's describing this tilt of a line that's occurring with the rate of change that's happening. So the steeper the line, the bigger the rate of change. The shallower the line, the smaller the rate of change. So again, these two things kind of go hand in hand. All right. So the last thing that's in your guys' notes is describing this type of slope that's taking place. So I have here 4 different graphs. So the first thing that you need to understand is we read slope left to right. Okay, we read slope left to right. So when we take a look at this, we need to imagine a car going on this line from left to right. All right, so if our car was here, I would be driving up the hill. If a car was over here, I'd be going down the hill. Here, I'd be going across the hill, and here I would just kind of be falling off the cliff. Each of these types of lines has names, all right? So this first one, because I'm going up the hill, this would be called a positive slope. Here, because I'm going down the hill, would be a result of a negative slope. Here, I can still sled, I can still go on this hill. It just happens to be that there is no hill, so this is 0 slope. And here, I'm falling off the cliff, which makes it undefined. And what this means is the slopes themselves, the fractions that we would be getting for these would be positive, a over b, some number over some number, a negative a over b. Here I would have 0 over any number. And here I would have some number over 0. So if I see the format of any of these fractions, there should be a visual line to match it to be able to identify it. So again, up the line, down the line, across the line, or falling off the cliff. Okay. Most importantly, though, with slope is, though, the numbers part of it. Okay, and we have a generic formula that goes with it. So slope is written as a fraction. That's a key. It is a fraction. And it has this generic formula, which we call rise over run. Okay, remember we are dealing with the change in y over change of x. Well, y is my up down. That's the rise, going up or going down. My change of x is my run. Running is left and right, and that's dealing with my x. Therefore, it's rise to run. We need to understand that rise is always going to represent our up-down motion, and run is going to represent our left-right. Now, I always refer to slope as our GPS. All right, it is my directions. How do I get from one piece of data to the next? We also need to understand that these words have symbols. So up is positive, down is negative, left is negative, right is positive. If you're ever confused with up, down, think of a thermometer. Left, right, think of your number line. All right, so we're going to go ahead and switch then to graph paper. And using this concept of up, down, left, right, we're going to find the slope of a couple of lines. Okay, so we're going to keep that kind of up top there. All right, so we're going to find the slope and rate of change from this graph here. All right, so I have a graph, it's on graph paper, and I have my data points illustrated. Okay, now the first thing that we're going to do is we're going to go ahead and we're going to draw a path. Now I'm only allowed to go up, down, left, right, and I want to get from one dot to the next. Please understand there's multiple ways I can look at this. There's actually 4 different ways. All right, I could go up 3, and I can go right 1. All right, I could technically go left 1, so if I went from this dot, left 1, and then down 3. I could go right 1, up 3. Notice I already have that written here in blue. Or I could have went down 3 and left 1. Again, already written in yellow. So while there's 4 different ways I could have ventured, there's 2 different combinations that I could have done. Okay? No matter which route I take, up, down always has to be the top. It is always rise, which is up, down, over run, which is my left, right. So in this case, I'm going to use what I have written in yellow, okay, because I want to point out what happens if I choose that route. So notice, although I went left 1 first, left has to go in the bottom. So I'm going to write left 1. And then I went down 3, and down is here at the top, so I'm going to write down 3. And then I need to change these words to their signs. Well, down is negative, left is negative, which means negative and negative really means positive. Which means when I go left to right, I'm going up 3 over 1, up 3 over 1, which is what this slope is telling me. So the rate of change of this graph is 3 over 1. Up 3, right 1, up 3, right 1. Positive fraction, positive line. So here's one for you to go ahead and do yourself. Okay, so take a look at it. All right, so again, how do I get from one point to the next using our directions? Go ahead and pause the video if you need. All right, go ahead and pause longer if you need so. But in this case, we would have been going down 1, right 2, which means negative 1 over 2 would have been my final slope. Okay. The final way that we look at slope is if I'm in table form. Again, you guys have already seen this with finding the second difference, but we're going to make sure we can find the first difference included with this. All right, so we're going to find the change that occurs from one data point to the next. So the question is, how do I get from 3 to 4? Well, that was a change of plus 1. How do I get from 5 to 7? That was a change of plus 2. So this rate of change for this segment is 2 over 1. Now I need to find the change that's occurring next door. So how do I change from 7 to 15? I get a pen that works. All right, how do I get a change from 7 to 15? That's plus 8. How do I get a change of 4 to 8? Well, that's plus 4. So here we have y over x, 8 over 4, which simplifies to 2 over 1. So the slope of this is 2 over 1. Right.